Hello everyone, today we are having a new topic and I'm really excited about it. And we'll talk about standardizing a distribution. How do we do it and why do we do it? So basically, when we standardize distribution, we make sure that the mean of the distribution is 0 and the standard deviation is 1. Why we are doing it? For many purposes. It makes it easier to compare one distribution to another distribution, and also it helps. For example, we are building a machine learning model and we have a distribution and we have some optimization algorithm. And when we have a standardized distribution, it actually helps the optimization algorithm to converge faster. And let's start with an example of a distribution. And let's say we have a distribution here. Let me draw the other line for the coordination system. And let's say this is 0. We have, let's say, this distribution. And this is basically the values of random variable x. And when we want to make the mean 0, we basically subtract the mean for from the every value of x, which is x minus mu. And x minus mu will be here. Let's say this was the expected value. Maybe something a little further here. And now it will be here. So something like that. So the first step of our standardizing standardization process, we basically subtracted the mean from every value of x. And if we plot the distribution again, we will wind up with something like that, the one that you're seeing below. And you can ask me why, when we do this operation, the expected value of the distribution becomes 0. And I'll tell you why. From the previous videos, you probably know that this is one of the properties of expected value, which is the sum of the expectation of a sum is the sum of those expectations. Which is this? So in our case, keeping this in mind, you know that we basically, this is the new distribution that we are looking for, because every value of random variable is the mean is subtracted by them, and this is the new distribution. And what is the expected value of this distribution? And the same thing as we're going to use this property mu, and you know that this is basically mu, right? Because the expected value of a distribution is the mean of that distribution, which is mu. And another property of the expected value is that the expected value of a constant is also, no, sorry, the expected value of a constant is 0. Oh, I'm really sorry. The expected value of the constant is also the constant. It's the constant itself. So it's mu. So mu um, subtracted by mu gives us 0. That's why exactly we get the value 0. And let's look at how we make sure that the standard deviation is 1. So we knew before that the mean is already 0, and what we want to do is we want to make the standard deviation 1. So we're basically changing the variance and making sure that the deviation is 1. So basically, we had a distribution of the random variable x, and when we divide every value of the x by the standard deviation, the the standard deviation of this distribution will be 1, and I'll tell you why. But before explaining that, I would like to go back to the properties of variance because we're going to use them. So variance of Cx, let's say, C is a constant, is expected value. You know from the previous videos that the variance of x is the expected value of x squared minus expected value of x squared. And with the same thing, what we do here is expected value of c x squared minus the expected value of c x squared. And after doing this operation, we can write it as expected value c squared x squared, expected value of c squared x squared minus c expected value of x and all square. We can do it right. And after this operation, we can take the c square and write it like this. Sorry. C squared expected value, because we are taking the c squared out of the expected value, we can do it. Expected value of x squared minus c squared expected x squared. Yeah, and then we also, when we take the c square here, we end up with c square multiplied by e x square subtract square. So as you can see, this is variance x. So we come up with this, the variance cx is c squared, variance x. So now we prove that when we take a constant that is inside the variance, it actually comes out, but as it comes out squared. And let's then look at you remember, like in the beginning we said, like this is the distribution that we're looking for. And when we do this, x by standard deviation, it's basically 1 divided by the square of standard deviation multiplied by variance x, right? Because this is basically 1 over standard deviation, and when it comes out, it's again 1 over squared squared standard deviation. And then when we take the standard deviation of this, what we do, we basically take the square root, right? So the standard deviation of x, what it becomes 1 over standard deviation multiplied by the standard deviation of x, right? Because I mean, when you take this here, you can write it as 1 over multiplied by variance x. This is basically standard deviation of x. And 1 over standard deviation multiplied by the standard deviation is 1. That's why when we divide the random variable by its the standard deviation, we get the standard deviation of 1.